So, difference between average and instantaneous. Do I miss maybe?
Oh,
no. Average is just like a slope between 2 points. Average velocity is like an average rate of change, just a slope. Instantaneous is the slope of the tangent line, or the slope at a single point. That's when we had to look at the tables to actually calculate it. What's a limit? So it's basically just the y value you're approaching as x gets close to a certain number. The formal definition. All right, I'm going to tell you, this is a multiple choice question on your test. Okay, 2 point question, right or wrong. If you know it, you're good. And if you can pick that out, it'll help you probably when you get to that epsilon delta bonus question that I told you might be on there. You can look back and say, okay, this is what I have to prove. So, if the absolute value of x minus a is less than delta, then the absolute value of f of x minus l is less than epsilon. That is your formal definition, that epsilon delta thing that we had to prove when we did the definition. Alright, to be continuous, there are 3 things. You need to know what they are. It means the function exists, the limit exists, and those are equal. Alright, number 4, there are lots of different options that would work. Coming in from both sides, it has to go to 1, and that needs to be an open circle. As you approach 3 from the left, it's going down to -2. As you approach 3 from the right, it's coming in to +2. When x is 0, your y is -1, that's a closed circle. And when your x is 3, your y is 1, that's a closed circle. Okay, number 5, 3/2 for part A, B, -infinity, C, -5/54, D, 1/2. If you missed it, just mark it, and that's what we'll talk about soon. E is infinity. Interesting. My lettering changed. It started going down instead of over on this page. F is -infinity. G, 1/3. H, -2. Number 6, if you factor the bottom, the 2 things on the bottom are 5 and -3, so it's discontinuous at both. Since the x minus 5 cancels, that one's removable. Since the x plus 3 is left on the bottom, it's infinite at -3 because of the vertical asymptote. Alright, number 7, you drew your graph. It should look like this, so you can see it is discontinuous at 0, and that is a jump discontinuity because you have to physically jump from one piece to the next. Alright, number 8, you graph it. It should look like that. B, 3, C, 0, D does not exist. E, F, and G are all 0. H is discontinuous at 0 and at 3. The reason at 0 the limit does not exist, and at 3 the function does not exist. Number 9, intermediate value theorem. You have to tell me it's continuous, and then you plug in your 2 points. The sign changes, so there's a 0 between them. Number 10, average velocity is slope. So we need 2 order pairs. Those are your 2 x's, so you plug them in, get your y's, do the slope between them, and you get 3. Instantaneous, that's when you have to do the table. So from each side, above and below, and you get 2.5. Number 14, it is not continuous at -4 and at 2. -4 is because the limit doesn't exist, and 2 is because the function does not exist. Number 12, your epsilon delta. So we're trying to prove the definition. If the absolute value of x minus 10 is less than delta, then 3 minus 4/5 x plus 5 is less than epsilon. So you have to find your delta. You do that scratch work, and we get 5 epsilon over 4. So your proof, you have to state, let delta equal 5 epsilon over 4. Then, if the absolute value of x minus 10 is less than delta, then and you go to your proof part. So you combine like terms, that's an 8. If you pull out the 4/5, you get 10 minus x. If you pull out the negative, it comes out as a positive, so that's x minus 10. But we know x minus 10 is less than delta, so that's less than 4/5 delta. But delta is 5 epsilon over 4, so sub that in and you get your epsilon. 13, vertical asymptote, x equals -3. Horizontal, you have to do the limits as you approach positive and negative infinity. I've told you if you do them at the same time, just make sure you're putting plus or minus infinity, and you get y equals -1. All right, 14, if we want this to be continuous, the pieces have to match up. So I jumped from this piece to this one when x is 2. So what I did is plug a 2 into each of them. The first one, if you factor, the x minus 2's drop, you get x plus 2. So if I plug a 2 into that one, I need it to equal the same. And so your a has to be 2. And so then you do the same thing here. These two connect at 3, so you plug a 3 into each, and your b should be 3/2. I did record that, so if you need to go back and look at that tonight for the answer on anything, if you're reworking, you can. So problem number 5, part A. We have the limit as x approaches -3 of x squared minus 9 over x squared plus 2x minus 3. All right, so you're going to have a lot of limit questions. Now, I wouldn't put it past me to just put one on where you can just plug things in to see if you're watching for that. We always check to see if we can put it in. If I just plug this in, I get 9 minus 9, so 0 on top, 9 minus 6 minus 3, so 0 on the bottom. Now, when can you not just plug it in then? If there's 0 on the bottom, that didn't work. So if you just try to tell me this equals 0, you just lost a ton of points. If I had like 0 over 5, would that be okay? Yes. So you check first to see if you can just plug in. And there'll probably be something that you can just plug in to see if you're verifying that. Since we can't, we have to find some way to try to get that 0 off the bottom. So with this type of problem, we usually factor. X squared plus 2x minus 3. That would factor into x plus 3, x minus 1. Then what happens? Those drop. And I'm also going to be watching that you're writing the limit on every step. When does it go away?
When you plug in.
Let's see if we can plug in now. So if I did -3 minus 3 over -3 minus 1, that's -6 over -4, which reduces to positive 3/2. Let's look at E. So we have the limit as x approaches -4 from the right of x plus 1 over x squared plus 4x. Okay, even though I'm approaching from the right, if I were to just plug in, -4 plus 1 is -3. -4 squared is 16, minus 16 is 0. So does just plugging in work? No. So we have to do something else. When you have these fractions with polynomials, we always try factoring and reducing. I have an x plus 1 on top. On the bottom, what could you do? Okay, did it just cancel out? No. So, unfortunately, our strategy did not work. What we need to do now is see if we can still figure this out. Okay? So, it helps to factor that. Then, if I'm trying to reason, on the top, if you plug in -4, we're getting -3. On the bottom, that x is a -4. -4 plus 4 is going to 0, but this is where the one-sided piece comes in. You are plugging in numbers bigger than -4. So you're putting in -3.9, -3.99, -3.999. Is that going to be a positive or a negative number when you add 4 to it? Positive. Okay, if this weren't a one-sided limit, I wouldn't be able to figure this out right now. So when we think about this, first of all, if you have a negative on top and bottom, what happens to those? Those cancel. It's just going to be a positive. if you have something, a number divided by a smaller and smaller number, what's it going to? If it were approaching from the left, it's a negative infinity. If it's approaching from the right, it's positive infinity. So what you need to remember, a number over infinity is turning into 0. A number, as you're approaching 0, a number divided by a smaller and smaller thing is going to infinity. So this is going to infinity. That's positive. A negative divided by a negative is positive, so this whole thing would turn into positive infinity. And again, the only reason it's that positive is because my two negatives cancel out. Really hoping my kids didn't leave windows open at home. I don't know if I trust them or not.
My mom usually has those newspapers.
Well, yeah, I know they opened them last night. I told them to close the windows this morning. I don't know if they did. Alright. Are we good for problem 5 then? Problem 10. It'll be fine. Alright, the displacement in meters of an object moving in a straight line is given by this equation. Where t is measured in seconds. Alright, part A. Average velocity. What is average velocity? Slope. To find slope, you need two ordered pairs. I gave you a specific interval between 1 and 3, so those are your two different times. So we need to get the y value for each. So if it's 1, if you plug in a 1, we get 3.25. If I plug in a 3, we get 9.25. Is everybody with me so far? So if I have this question on the test, you'll know what to do. Plug in your two times to get your two ordered pairs. Now we find slope. Slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So we get 6 over 2, which is 3. We were measured in meters per second. So that's part A. Alright, part B. I want the instantaneous velocity. So, instantaneous, what do we have to make? Make the charts. Now, if you don't have a calculator, are you probably going to be able to make this chart? No, so it'll be like when I put it on the quiz, I gave you the chart and you just had to be able to interpret it. The instantaneous velocity is asking what these slopes approach. We want to compare it to when t equals 1. So basically, we have to do times smaller than that. So 0.9, 0.99, 0.999. And we need to do times bigger than that. 1.1, 1.01, 1.001. And what we need to do is calculate the slope. So we'll have to plug those in to get our position, and then we can do the slope. So I'm not going to work through all of these, but let's do one or two of them so we make sure we know what we're doing. So for the first one, if I plug in a 0.9, we get 3.0025. So then you do your slope. Y sub 2, 3.25, minus y sub 1, 3.0025, divided by x sub 2, so 1, minus x sub 1, so 0.9. And you get 2.475. Does everybody know where I got these numbers from? If you continue to plug in, you get 3.225, 3.2475, and these are turning into about a 2.5. Do the same thing from over here. Do I need to show you where I'm getting these at all? So I plugged them in, and these were the values I got. So my instantaneous, what value is this approaching? 2.5. It looks like both of these tables, they both turned into basically 2.5s. Okay, so on the test, I would have to give you something like this and ask you what value you were approaching. If I ask for average velocity, what am I asking for? Slope. Instantaneous is what those slopes are approaching. Do you guys understand the difference? I'll probably ask you about that somewhere on the test. So you'll have to find both, and I may ask you, how am I getting that? All right. Next question. Number 12. Okay, so earlier on the study guide, I asked you for the formal definition of a limit. So the actual definition of a limit is if the absolute value of x minus a is less than delta, then the absolute value of f of x minus L is less than epsilon. So that's the definition for the limit as x approaches a of f of x equals L. So your formal definition is with the epsilon deltas. So our goal on problem number 12, we want to show the limit as x approaches 10. So if the absolute value of x minus 10 is less than delta, then the absolute value f of x, my function, was 3 minus 4/5 x, minus my limit, which is -5 minus -5 would be +5. It's less than epsilon. So that's what we have to do. We have to prove that. First step is our scratch work to find delta. So we start with this part. Add like terms. We're trying to get x minus 10. So I'm going to pull out the coefficient on my x, which is a -4/5. So if you take that out, you get a positive x. 8 divided by -4/5 is -10. The absolute value of -4/5 is +4/5. And how would I move that to the other side? Divide or multiply by the reciprocal. So the absolute value of x minus 10 is less than 5 epsilon over 4. So that's what my delta needs to be. Step 2 is the proof. Everybody with me? So you start out with your delta. We need to let delta equal the 5 epsilon over 4. Then we do our condition. If the absolute value of x minus 10 is less than delta, then the absolute value of my f of x And now we're basically repeating everything we did up there. So you add your like terms. We can take out the negative 4/5, but the absolute value of negative 4/5 is a positive. But you know, we've already said that x minus 10 is less than delta. So this has to be less than 4/5 delta. But what's delta equal to? Which equals epsilon. So you're done once you can get that less than and your epsilon in there. So we are proved it.
Do we have to rewrite the equation at the end?
No. Is that okay? Problem 13. Right. You might as well go ahead and do the whole problem. It doesn't take long to do the vertical. How do you find the vertical asymptote?
What is the zero?
So if I set 3 plus x equal to 0, I get x equals negative 3. So that's my vertical asymptote. If I gave you a graph and asked you to find the vertical asymptote in that, could you do so? And remember, if it's vertical, the equation is x equals. If it's horizontal, the equation is y equals. So make sure you could get that from a graph as well. To do the horizontal, we have to do the limit as x approaches. We need to do both positive infinity and negative infinity. When will those be different? If we have a square root. Do I have that here? So we know they're going to be the same, so if you want to check both at the same time, you can. As long as it's just a polynomial divided by a polynomial, they're going to work out to be the same. Okay, if I just plugged in right now, I get 4 minus infinity over 3 plus infinity. Is that helpful? So what's our trick when we are doing these limits at infinity?
1 over 3 is 4.
X approaches positive negative infinity of 4 over x minus 1 with 3 over x plus 1. Now, a number over infinity turns into 0. So we have 0 minus 1 over 0 plus 1. So we get negative 1. So the horizontal, you need an equation. Vertical is x equals, horizontal is y equals.
What did you say the equation needed in order to do the positive and negative infinity?
If it's got a square root or a piecewise, you would need to check the two separately. Is that one okay? Let's look at problem 14. Okay, so we want to make this continuous. If it is continuous, if a piecewise is going to turn out to be continuous, then when you graph it, those pieces have to match up, right? So we have this piece if x is less than 2. We have this piece if x equals 2. And this piece if you are between 2 and 3. And this piece if it's bigger than 3. Okay. So let's talk about the first one first. If I want to find the a, then these two have to match up when x is 2, right? So if I plug in a 2 for my x, these have to be alike. Can you plug a 2 into the first one? What do I need to do to that so I can then? If we factor the top, those cancel. So that's a discontinuity. What kind of discontinuity is that, guys? Removable. Good. Okay, so now I know that I need x plus 2 to equal this ax when my x is 2. So if you plug in a 2, you get 4 equals 2x, so the x has to be 2. Sorry, that's not x, that's a. Okay. Now let's talk about my b. We have 2 of these that have a b in them. When will these 2 things be equal to each other? When do those have to touch? At 3. So what I need is x squared minus bx plus 3 to equal 2x plus b when x is 3. So if I plug in my 3, okay, we get 12 minus 3b has to equal 6 plus b. Subtract over my 6, add my 3b, divide, and b has to equal 3/2. So we have, good, we hadn't done one of these infinity ones. Okay. If I just plug infinity in right now, do I know infinity to the negative infinity to the 4th plus negative infinity to the 5th? Do I know what that equals? No. What was our strategy on this? Factor. So we could take out x to the 4th. So there'll probably be something like this on there. If I then were to plug in my negative infinity. Okay, let's see how that helps me. If I put it into the original, you had negative infinity to the 4th plus negative infinity to the 5th. If you take a negative number to an even power, it's positive. So this just gives me a really big positive number, and this is going to give me a really big negative number. But do I really know what that's going to from there? Is it obvious? No. So that's why that didn't work. Now down here, if you have a really big number to the 4th power, the negative would become positive, so we're just getting a really big number. If you have a really huge negative number and you add 1, what is it? If you multiply a positive and a negative, you get negative infinity. So that wasn't obvious from up here. When I added positive infinity and negative infinity, that wasn't clear. It could have turned into 0, it could have turned into positive infinity, could have turned into negative infinity. So we had to factor it first so we could reason through that. So on those, if it's just a polynomial like that, we can't do our trick of dividing by the highest power of x because it's not a fraction to start with. So we factor and reduce that way. Okay. Anything else?
Could you do one like H?
Yeah, you want a radical one? Okay. So let's say I gave you, this is dangerous, let's hope it works out. The limit as x approaches infinity of squared minus x minus the square root of x squared plus 3x. Okay. If I just plug in infinity right now, do I have any idea what this mess is going to turn into? No. When we just did the polynomial one, we tried to factor first. Do you want to try to factor with all these radicals? No. So what could we do? Conjugate. Anytime we have radicals, we usually go to our conjugate. So we can think of this as over 1. So the conjugate is the exact same thing, but you change the sign in the middle. So we get the limit as x goes to infinity. Okay, when I FOIL the first two, that radical cancels. Minus square root plus 3x over the bottom. Can I change something real quick? Because I need this to work out different. Can I make this a plus x right there? Sorry. These problems have to be very carefully designed to actually work out to something you can solve. Okay. What do I need to do right now? What should I do with this minus? Okay. Then positive x squared and negative x squared cancel. Positive x minus 3x is negative 2x. Okay. Is it possible to figure out what this is turning into now? If I plug it into the top, I get negative infinity. On the bottom, we're adding lots of really big numbers, so the bottom is infinity. Negative infinity over infinity, do we know what that turns into? So what do we do? Highest power of x. Okay. So this is just an x, so I need to multiply by 1 over x. Whatever you do on the top, you must do on the bottom. But on the bottom I have radicals. So 1 over x is the same thing as 1 over what? Square root of x squared. So we're multiplying by equivalent things, but on the bottom, since I need to take it under the square root, I'm thinking of it as an x squared. So negative 2x divided by x is negative 2 on the bottom. X squared over x squared is 1. X over x squared be 1 over x. 1 plus 3 over x. Everybody with me there? Those are about as complicated as they get. We've had, a lot of tricks here. The conjugate, multiplying by 1 over the power, having to bring that under the radical. Everybody with me there? This is a high point value question. So the top is negative 2. On the bottom, I get 1 plus 0 plus the square root of 1 plus 0. Square root of 1 is 1, so negative 2 over 2 gives me negative 1. Okay, let's say I give you this graph. I'm going to ask you some questions. What if I said the limit as x approaches negative 3 from the left? So if you are approaching from the left, that means you're coming in on things smaller than your negative 3. So what's my limit? 1. What if I ask for the limit as you approach negative 3 from the right? Negative 3. If I'm coming in from the right, we're going down here. Negative 3. What if I asked you for the limit as x you for f of -3? 0. That's where the actual point is on the graph. Okay, what if I asked you where it's discontinuous and why? So where is this graph discontinuous?
-3, because the limit doesn't match. The limit does not match up.
The limit doesn't exist at -3 because, like we just said, the two-sided limit doesn't. Where else is it not continuous? And why? The function does not exist. What if I had put a point up here? Then what would be the reason? The limit doesn't equal the function. Right, because we still have a limit as I'm coming in from the left and right. They do match up, so there is a limit. If I put this dot, there is the function, but they're not equal. Okay, so if I'm asking you why something's discontinuous, I'm expecting you to tell me which of those 3 rules it breaks. So you need to know your 3 rules. Alright. Is that one okay? Let's say I gave you this, and I asked you where that's discontinuous and why. What do you need to do? Factor. Okay, so the top would factor into x minus 5, x plus 1. What's the bottom factor into? So what happens? Those cancel. So it's still discontinuous twice because the original had 2 things on the bottom. So what makes x minus 5 equal 0? 5. And what makes x minus 2 equal 0? 2. Now your reasoning. If something cancels, then it's what kind of discontinuity? Removable, because it's just going to put a hole in our graph. If it doesn't cancel, that means we're going to have a vertical asymptote, so it is infinite. What's the third type of discontinuity? Jump. When do we get that? Piecewise functions. When you have a graph that physically jumps from one piece to the next. Yes?
Can you do one where we have to like make one?
Where you have to draw the graph
Yeah.
and find, okay. Let's say I told you f of x is all about I don't want to make it too hard, do I? I want it to work. Okay. So when you do piecewise, what do you have to do? Graph them separately. We usually do T-charts. So for this first one, it says for x does not equal 0. Does that mean I don't plug in the 0? It's just going to be an open circle. So if I put in 0, it will be open. And we just need to pick enough points that we get the idea of the graph. So if I put in 0, what do we get out? 4. Okay, if I put in 1, we get out -1 plus 3 plus 4, so we get 6. If I put in a 2, I get -4 plus 6 plus 4, so that gives me 6. 6. Why would those be the same? What's happening between them? If it's x squared, what's your graph going to look like? A parabola. So basically, in between these points, it went up and then it's coming back down. We could always put in more points if we wanted. We could do like a 3, and we get 4. You know, you could put in a -1 if you wanted, but you just need enough to get the idea of your graph. So we have this parabola. Everybody kind of get that? So just pick points until you get the shape. And then, how do I graph this second piece? Yeah, it's just a point. When x is 0, my point is 5. So where is this discontinuous? Okay, I told you a lot of times piecewise functions are jump. Is this one jump? No. What is it? When you just have a hole in your graph, that's removable. The reason this one turned out to be removable is because we had the does not equal and the does equal. When it's one thing if x is greater than and another when it's less than, that'll always turn out to be your jump. Okay. So far so good? We don't have much time left, do we? What if I gave you limit as x approaches 0 of that? Can you just plug in? No. So what do we do? Conjugate. So when you multiply those, the radicals cancel. -1 times 1 is -1 over x times all of this. Then what happens? -1 and 1 cancel. Then what happens? X's cancel. What does that leave on the top? 1. And now you can plug in. So square root of 1 is 1, plus 1 is 2. So we get 1/2. I feel like we have talked about almost everything on there. We've done the questions you asked. We've pretty much did everything. We didn't do one like example 4 where you have to make your own graph that meets those conditions, so make sure you know how to do that.